Assalamu alaikum wa rahmatullah. Good morning, everyone. My name is Fuad Qudsi. I'm a lecturer in mechanical engineering Abu Dhabi campuses. Today, I will speak a little bit about a workshop that I have attended, and also a courseware that we have already at ADM that we started this semester to use, and we started to use this semester, and then we are going forward implementing this in labs, and then looking forward to have senior design project maybe or research. So the main courseware we have, that is a Qube-Servo, that is from a Quanser, and then the system hardware. The Qube-Servo is a compact teaching platform for learning control systems and mechatronics. It features a DC motor modules and an inverted pendulum, enabling hands-on experiments in PID and state space control. Okay, let me check here. Yeah, you can hear me?
Good morning.
Good morning. Can you hear me?
I can't hear anything. I hope you can hear me.
Oh, yeah, I can hear you. Thank you. Thank you. Okay, very good.
Something on my side. Okay, it's probably something on my side.
So I can hear you. So as I said, Qube-Servo 3 is a compact teaching platform for learning control systems and mechatronics. It features a DC motor and modules like inverted pendulum. It enables hands-on experiments in PID, state space control. It is integrated with MATLAB and Simulink, and it offers a practical way to apply real-time control concepts in labs and classrooms and research. Then, as we see here, that is the hardware we have, which is in which we have the inertia mass disk module, which is connected to a motor, and it is controllable by DC motor. And then we have also inverted pendulum module that is also used with this Qube-Servo. And then this is a complete system with sensors, okay, and feedback control. As for the data acquisition system, this system has different modules, and before we have it with LabVIEW. We used to use it with LabVIEW. Now the upgraded versions, we are using this with the Simulink and MATLAB. The system schematic, it is we have the DC motor or the pendulum. Okay, we can use one of them at the time. Then the motor can connect the inertia disk or the pendulum, and then we have, for both of them, there are the encoders which sensors and gives the reading for the feedback. And then there is the data acquisition system, which is connected to the PC microcontroller or PC, where we have the LabVIEW installed on the computer. And then there is the amplifier that is to amplify the signals. The interfacing using Simulink. In Simulink, we can. There are the software is already. We are using a Quark. Okay. From the Quanser, and then we have the hardware in loop. Okay, hardware in loop. Then this is the Quark represent the the module which connects the software to the hardware. So in here in this window we can set the board type to be used. Okay, now for this kind of equipment we have the Qube-Servo 3, which is almost the same, an updated version of Servo 2. And then here under this list, there are the different kinds of Quanser's platforms we can define. Then we have only to configure the data acquisition system and starting using it. So at the end of this class, at the end of this PD, I hope I will have the time to show you some other platforms used in teaching mechatronics, robotics, and control systems from Quanser. Yeah, then here we have the hardware in loop for reading, okay, where I can read, okay, from the control system. Okay, and then here I have to put some definitions to configure the hardware in loop, which input I'm reading. And then we have, there are also the hardware reading and writing. Then writing, I can give signals to the hardware, and then reading, I can read from the software. And then for the scope, I can read the response of the system. So how this is good in teaching control for students? We have the DC motor courseware overview. We can, with this equipment, we can teach different kind of different courses, okay, different topics. We have, as for instrumentation, we can teach hardware integration and filtering. Modeling, we can teach step response, frequency response, block diagram, parameter estimation, state space control, and friction identification. We can also teach system analysis, like stability analysis, second order system, Rutherford's test for stability system, and Nyquist. Also, we can teach control. Okay, then that is in control design 1. We are still in undergrad. For example, we can teach proportional control, PD control, PID control, and lead compensators. And for control design 2 and discrete control, those courses we can still teach them for graduate. Okay, then in the future, if we think about, okay, like giving some courses for industry, then those they might be quite useful to use with this equipment. We have the steady state error, load disturbance, robustness of the systems. We have also discrete control, discrete stability, and discrete control design. In terms of the pendulum as well, there are also courseware where we can use also, we can teach modeling, moment of inertia, pendulum modeling, state space modeling also as well. And then for the control design, we can teach balance control, swing up control, LQR control, and pole placement control. Okay, then those are those are a combination of undergrad and graduate level courses. Then for the courseware for this equipment, we have the laboratory. We can design our course according to our needs, and then it is a complete solution to teach. We have also we can set up we have the setup provided with the equipment. As for experiments, there are different. We have the DC motor, which is the base unit, and then the inverted pendulum. Then in here we can see, for example, different kinds of labs. Okay, that is like huge labs we can implement to teach our students. And then, for example, there is the mapping guide, which shows us the lab experiments against the textbooks. You know, as for example, for textbooks, there are a lot of textbooks that teach control systems. Okay, and then in this we have, for example, it identifies the lab experiment against the textbook. Like for example, if I look here, there is the automatic control systems, which is this book. It includes different, okay, almost all types of experiments that I can run. Then if I decide, for example, to go with this textbook, then I have a complete set of experiments that cover the theory, and then I can link between the theory and the practical to grant the students the best education, applied education with the technology. Then here we have also this is a continuation of the mapping guide. Then here we have a continuation of the experiments at here, and then at the left, and then we can match. We can see different textbooks which educates the scene. Okay, then what is the Qube-Servo DC motor experiment? And what we can the students learn. Then the Qube-Servo experiment. This is the hardware. It can be board using. It can be board, and then it can be connected using data cable to the PC, where we can control the experiment. We have the DC, and then we have the inertia disk. And then this will educate the students the motion control, which is used in many places in industry, in many applications. And then we have also the pendulum, okay, which is another set of experiments, wide experiments, in which I can teach the students the undergrad level, and mainly we can use this also for graduate level and research. Then those are some applications, for example, for the inverted pendulum. Then for the lab demos, what kind of modeling labs I can teach the students using the Qube Quanser? I can teach them the step response modeling, frequency response, block diagram representation, parameter estimation, state space modeling, and friction identification. Then those labs are very handy when it comes then they are very handy when we use to teach the students. Okay, there are some videos I have here, but apparently they are not working. I will stop sharing this, and then I will share the PowerPoint. Okay, let me share the share screen. No, share file. Okay, let me share the screen or application. Okay, I hope you can see me. You can see the slides.
Yes, we can see.
Okay, let me show you. Okay, then here it shows a demo for step response, for example. Where I have here I have in the window, it shows the response of the system, and then down there we can see, okay, the response for the system. Then here we can see the modeling, which is in the software, okay, and then the responses. Okay, then the block diagram for modeling, this is the represent the motor modeling, okay, and then there is a lab for students. We can teach them how to model the system. Then here we can see the implementations. Okay, now the good thing is this equipment, it comes with almost like a lot of support in terms of the Simulink diagrams. Then in here we have this diagram is already built, and then it almost integrates a lot of things. And then there are not much to put in terms of coding and different things. Then here modeling. Then, for example, then it shows, for example, it teaches the students for in the experiment to do the simulation, okay, and then do the experiment, and then compare the simulation with the experiment, and link the theory to the practice. In terms for this course also, or for this equipment, in terms of system analysis, we can teach the students the stability analysis, second order system, Hurwitz stability, and Nyquist stability. Some of them, they are advanced. Okay, then this is, for example, we can teach the student the second order systems. Here we have the block diagram, and then this is the response from which he will get from the experiment. Okay, then this is, for example, a demo for the second order system. Okay, then as you see now, the desk will rotate for identified angle. Okay, and then here it shows the response for the system. Then this block, the response, the student has to read it. Okay, has to have this. Okay, and then identify the parameters of the system, which is something he already studied in the theory. And then this experiment will be a very good application of the theory. In terms of the control design, there are a lot of things for proportional controller, MIDI control, lead compensators. Those three controllers, they are widely used in industry, which gives the students the hands-on on the applied technology. And then the remaining also, those I hope in the future we can design an advanced course for graduate level, or have research on this. Okay, then in here it shows also the PD motor position control, which is a controller. And then here the experiment resulting from this would show. Okay, then here also a demo for the PD motor position. Then the students will be able to touch, okay, physically, the physical meaning of changing what is the proportional controllers or the derivative controllers, and then what are the effects they have on the system response. So by the end, he will, at the end of the experiment, he will see, for example, the proportional control only when we have a lot of overshooting and oscillations, and then he would compare with the PD, proportional derivative control, where it shows directly how the derivative controller decrease the overshooting on the system. For the discrete control, this is something way for example, I know some faculty might be interested in this for research applications. We have the introduction to digital control, discrete stability, and discrete control design. And then for the other equipment, the other module, we have the pendulum modeling. We have the moment of inertia, pendulum modeling, and state space modeling as well. For the state space modeling for the pendulum, then this is something we can teach the students, the modeling of mechanical systems, which is good. And then how it can implement it. For example, in here we can see, we have the state space model, for the theory, for example, where the student, he has to come up with the state space model, and he has to compare with the experiment. Then here, for example, a demo for the state space modeling. Here it shows the experiment with the theory. For the pendulum control, we have the pendulum balance, and then swing up, LQR state space, state feedback balance control, and then pole placement, state feedback balance control. For the ball placement, this is something we had before, but this is some for advanced control. Then this is a demo for the ball placement, balance control. Also, there are the pendulum swing up, can be done analytically using a nonlinear control. This is a little bit advanced for graduate level. Then this is something like I wanted to show to the faculty about the Qube-Servo 3 that we have already in ADA, and then in some of the campuses they have already. As we have different departments, like we have the mechatronics now, and electrical, and also aviation as well. Then it might be, for example, some faculty might, for example, use the same equipment, or if they have a senior design project where they have to where they wish, for example, to their students to work on something, then we have this available, and then we are always here to assist in any kind of help for mentoring or co-supervision. Any questions for this presentation? The other thing I want to show you, which is the cyber physical systems, which are good also to integrate in our courses. Okay, then for Quanser in general, okay, the one we have now so far, we have the Qube-Servo that I have presented, and then here we have different things which are good, might be good also to have. Then there is the Aero2. Okay, the Aero2, which is a dual rotor aerospace platform that is used for teaching and research in flight dynamics and control. It supports the configuration like the 1 degree of freedom or 2 degrees of freedom helicopters, enabling hands-on experiment in pitch and yaw control, BID, state space, and LQR control. It comes with built-in sensors, amplifiers, and full MATLAB Simulink integration. It is good and ideal for exploring real-time control in aerospace. Then I will run here a little demo about this. Okay, then this is something like last time I attended in the workshop. Also, okay, one of the things also that is good to have for our programs like the Qubot, which stands for Quanser robot platform. It is an advanced mobile robotics system designed for teaching and research in control systems, robotics, and mechatronics. It provides hands-on learning environment for students to explore key engineering concepts like the autonomous navigation, real-time image processing, sensor fusion, and Simulink-based control. And it is equipped with onboard sensors like LiDAR, encoders, and cameras. It enables a wide range of experiments from basic motion to complex applications. It's seamless integration with MATLAB and Simulink, and it is ideal for academic settings, okay, experiments, learning, and supporting delivery curriculum delivery in robotics, okay, and mechatronics as well. Okay, then this is a demo for a robot. Also, those this kind of equipment also they have virtual thing for simulation, can run virtually online and then face to face. There is also, this is the Qube-Servo, which is a small autonomous vehicle. This platform is developed for teaching and research for self-driving technology. It has strong abilities to handle real-time tasks like camera and LiDAR data processing. It comes with many built-in sensors, including LiDAR, depth cameras, 360 degrees vision, internal measurement unit, and wheel encoders. It is good for experiments in navigation, mapping, and control. It supports programming in Simulink and MATLAB, Python as well. It helps the students and researchers explore real-world topics such as autonomous driving, AI-based also perception, and vehicle-to-vehicle communication in a safe and hands-on. Also, there are one thing which is okay, the drones as well. Okay, the quadcopter drones, which are good also for teaching dynamic and autonomous vehicles. Flight dynamics as well. Also, there are, which is this interesting thing, which is okay, the Quanser arm or Q arm. This is a compact 4-degree of freedom robotic arm for teaching manipulators robotics, and it features an onboard camera and supports hands-on labs in kinematics, visual servoing, and pick up place to place task. It uses USB connection and integration with MATLAB, and then it can be programmed as well with Python. And also this is the QR. Also, it can be integrated with the robot as well. It can be mounted on the robot. Those two things, they can be mounted on the robot, and then they can also used in logistics as well. So this is something I wanted to share with you about the Quanser equipment application, and mainly the Cube Quanser. I'm open now. If you have any question regarding the equipment or regarding the technology, please go ahead. Thank you.
Dr. Fuad, can you hear me?
Yeah, thank you.
Can you hear me?
Yes, I can hear you.
Oh, great. Yeah, I was late in joining it because of my audio. It turned out I had to use Chrome in order to get to be able to
Ah,
hear
yeah.
you. But it appears that this is this tool, this software and tools, also hardware and software, can be used for mainly it's for implementing and testing controllers, right? For the controls course. What I wanted to ask you is, you mentioned something about applied dynamics, something that I may have to find out more if it can be useful in a course I may be teaching applied dynamics. Can you elaborate on that a little bit more? Which part of this software and hardware can I take advantage of in terms of lab?
Yeah, yeah, right, right. Let me
Is-
share with you. Yeah, let me share again with you the entire
the
screen.
reason I'm mentioning this is mostly you talked about controllers,
Right.
controls, but in
Mhm.
applied dynamics we don't care about that, So I wanted
Right,
to see if
right.
there's something. Yeah.
Mhm. I got your question, Dr. Menji. Now, for example, in Dynamics, there are the modeling as well. Okay, there are the modeling. We have the inertia disk here, right? And then we have also the pendulum. One of the applications, for example, for dynamic vibration, right? And in which, for example, if we have, okay, if you have the output, okay, modeling, for example, in Dynamics, this is completely can be done using this tool. And also,
Yeah, it's more like vibrations,
yeah.
vibration
And
force.
then I know from the test, yeah, I know from the from our colleagues like who taught the Dynamics, they were using the Simulink, all right? And then in here in the Simulink, we have complete environment where they can uh, see. Now, for example, for the Dynamics, the students when okay, the students when they run the lab, they will have a response for the system. Okay, then this response from the system, they can run the system identification, right? For example,
Possibly.
yeah, there are many things. For example, if you think about it, there are a lot of things you can integrate as well.
Yeah,
I
we
can
need
help
to
you.
know more about it, just to see if we can squeeze out some labs for for the courses. My second question is, does this company produce same for other disciplines like thermal science,
They are
fluid?
mainly in control. They are
It's
mainly
open.
in yeah, they are mainly in control. They are robotics control.
They're mainly in controls. Oh, okay,
Yeah,
okay.
this is Canadian company, Quanser. Quanser stands for question and answer. They made it the Quanser. They are mainly in control and robotics. Yeah.
Yeah, very good. Thanks.
Thank you. Okay, what is interesting here is the kind of the maybe if we think about the projects for students. Now, currently we are having an industrial contact for sway vibration sway control for steel, Emirates Steel. And then we are thinking to use this equipment in order to develop the model and control the system based on this, based on small system modeling.
Can you go back to the slide? I think you tried to show us something about the drone, but for some reason the animation did not come up.
Yeah,
Because we do that here in CDP. I want to see if we can use it for that purpose. Drone. testing.
Yeah, the drone. Actually, the drone. I had like a presentation about the drones, but we don't have them. Okay, but this is something I'm carrying on here to show you some, for example, some of the features like that they have. Okay, then those, for example, this is for aerodynamic. This is the drone. I witnessed some kind of research that is for propellers to study the fatigue, okay, of the propeller based on this system. But those equipments, we don't have them. We have only the Qube-Quanser. From this, I have only the Qube-Quanser, but others we don't have. Okay, but that is something like equipment they do exist maybe in the future. We might think about the other programs like the mechatronics and maybe aviation if they are interested as well. Then this is, for example, also the Q-arm. It shows 2 degrees of freedom, teach the aerodynamic and control. Yeah, for the thank you, Dr. Mohd. For the Qube, we have in Abu Dhabi, we received 10. We have 10 units for the Qube. We are using them, and it's good. They are very good. We use them to teach. We started from last semester, and this semester also we are teaching the student. We are using them. They are quite helpful. Thank you. Any other questions? Okay, thank you for coming. I really appreciate your time and wishing good collaboration in the future. Thank you.